Okay, welcome back, kiddos. Now we are wrapping up our Unit 9 review for our DCP. So this is going to cover everything for our final DCP. So let's get right into it. Let's get out our Unit 9.1 notes. And this lesson talked about the Pythagorean theorem. Okay, and so we said that only describes a right triangle. When we know it's a right triangle, okay, when we know two of the legs, we can two of the sides, we can figure out the third. All right, we said if we set it up a squared plus b squared equals c squared, where the a squared and b squared are the legs. Okay, legs are the ones that are on either side of our right angle. Okay, those are the legs. The hypotenuse is always the longest side, and it's always across from that right angle. So we always just put that the hypotenuse right over there. Okay, so if we just set it up just like that, then we can figure out any of the sides. Okay, so that's the main thing on this one, and then we could tell if it wasn't equal, if the longest side, okay, if it points away, so if is greater than the square, the sum of the squares of the other ones, then it's obtuse. If it's less than, then it's acute, and we set it up like that. Okay, so get right into some. All right, let's see on Unit 9. Okay, so this one says, this is a level 1 question. All right, solve for the missing side. Okay, that's what we're trying to find. All right, so it says City of Mesquite has a section of grass in front of the courthouse that is in the shape of a right triangle. Okay, so we'd want to underline or circle that or highlight that when we're taking the test to recognize that's what they're talking about that we need to focus on, right? Which of the following is the best estimate of the perimeter of the section of grass? Okay, so that means perimeter means add all sides. Okay, so we know that this side is 5, this side is 12. If it's a right triangle, then we can use the Pythagorean theorem to figure out this side, right? So we need to figure out this side first, right? So the first step we need to do is calculate the third side, right? And then second, we need to calculate the perimeter. All right, so let's do it. So since we know it's that, we can say a squared plus b squared equals c squared, right? Because we can use our Pythagorean theorem. So let's set it up. The main thing is what goes over here, right? So which one is that? Well, we know that this is a 90-degree angle, so we know that the hypotenuse is the one right across. So that's going to be the 12 squared. Okay, we definitely don't want to forget that squared. Okay, so now we know this side is 5. So which one is it, a squared or b squared? Actually, it does not matter. Okay, so we're just going to put it for there, and since we don't know that one, we can put it for b squared, or we could put x squared if we wanted to, either way. All right, so let's just go from left to right. So I like it. A lot of students will start with that. That's great. All right, so 5 squared gives us 25, right? Plus that b squared equals 144. Right, because if we put that in the calculator. So then we're trying to get to this, and then we know we have to take the square root at the very end to get to b, right? And then once we found that, so we can just put x there or b, whatever. Okay, so now we need to subtract 25, right? We've got to subtract 25 there, we've got to subtract 25 there. Those cancel out. So b squared equals 119, right? So then what's our final step? Okay, then we have to take the square root. So we'd say the square root of b squared equals the square root of 119, right? Which is going to be equal to approximately 10.908, which is 10.9, right? So let's look. Which one's the correct answer? Well, we need to, if we pick D, that would be wrong because that's just the third side. So the third side is that. So we're just going to circle that. Okay, so we need to do number 2, which is calculate the perimeter. So second step is going to say perimeter is equal to 5 plus 12 plus our 10.9, right, which is going to be equal to, put all that in our calculator, that's going to be 27.9. So that's our final answer. So that's a little tricky. So the C would be our final answer. D is wrong because that's just the side, right? Okay, next. We're going to talk about, we didn't spend much time on this, but it says identify if a set of 3 side lengths form a Pythagorean triple. Okay, so what a Pythagorean triple is it is a set of 3 whole numbers that form a squared plus b squared equals c squared. So it's in that form to where it would be equal to it. And they have to be whole numbers. Okay, that means whole numbers mean no decimals, right? And that's what whole numbers are. So these are some common Pythagorean triples and their multiples. So like in construction, if we so 3, 4, 5. If I knew one side was 3 and one side was 4 and it was a right triangle, I know the third side is 5. Okay, so also 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are called triples because, say, if I multiplied times 2, right? If I know one side is 6 and the other's 8, and it's a right triangle, I know the third side has to be 10 because I would multiply each of these times 2, right? If there was times 3, it would be 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. Same with these right over here, right? 5 times 2 is 10. 12 times 2 is 24. 13 times 2 is that, right? 5 times 3, 12 times 3, 13 times 3, right? And so that's what Pythagorean triples are. Okay, these are whole numbers. All these are whole numbers, so they have to be whole numbers, not decimals. All right, so let's take a look at what a problem would look like. So it says, which of the following right triangles have side lengths that are a Pythagorean? I go ahead and write that in there because I didn't copy it out. A Pythagorean triple. Okay, so which ones of these side lengths are a Pythagorean triple? So these might be, this is not a complete list. This is not a complete list. There's actually unlimited. It's infinite number of them. So here's how we do it. The first step is we're going to try a squared plus b squared equals c squared. Okay, so we're just going to see it. So if this is, then this should be a whole number. Okay, so let's try that. So that's what we're trying to find, right? That's going to be the c squared. So let's set it up. We would say 40 squared plus 32 squared. Okay, so if we put that into our calculator, that would give us, right, if we put this into our Desmos, that would give us 2629 equals c squared. So we're going to see when we calculate c if this is a whole number. Okay, so how would we get from there? If we're at c squared, we need to take the square root of it, right? Well, if I take the square root of that side, that means we have to take the square root of that side too, right? So that would give us c. If we did that, it would give us a decimal. It'd be like 51.22. Okay, so since that is that, it would be no, right? Because it's not a whole number. Okay, so that's why A would be incorrect, because it's not a whole number. That's what we need to recognize. Okay, so if we tried C, we would see that that one is also wrong. We would see that D is wrong. And then if we did this one, right here, we see it's a triple, but here's how we would check it, right? We would say 5 squared, right? Because if that's our c squared, right? 5 squared plus 12 squared equals c squared, right? And that would be 25 plus 144 equals c squared, right? And that would be 169 equals c squared, right? And that would be the square root of c squared equals the square root of 169, right? Which would equal 13 equals c, right? And so since that's a yes, because why? It's a whole number, right? That's a solid answer because that's a whole number. This is a no because this is not a whole number. Okay, so that's what a Pythagorean triple is. All right, so let's move on. Okay, so next, those are the major ones for okay, so now let's go ahead and take a look at some of these questions over here. So let's go ahead and skip this first one right over here. Okay, and it says this next one, Pythagorean triples practice where they find the third side just by knowing the triple. So 3, 4, 5 in its various forms, also 5, 12, 13, 8, 15, 17 in those. So say they gave 6 and 8. Okay, you would know the third side would be 10, right? Because it's times 2, right? So what if they said it was 10 and 24, right? You would know the third side is 26, right? Because that's times 2. Okay, so that's what they're talking about. All right, next. The area of a rectangle is 99 square meters. Okay, the length of the rectangle is 11, so that's important math information. We want to circle or highlight that. Find the length of the diagonal. Okay, so they don't have a picture of it, right? So let's just draw it. Let's first talk about the area of a triangle, right? So we have to know what that means. All right, so the area of a rectangle, what's the formula? Rectangle is base times, let's just do it like that, base times height. Now you can't go wrong by putting it in parentheses. Base times height. So the area of a rectangle is base times height. So let's go and highlight that if you forgot that. So let's go ahead and check this out. All right, it says the length of a, so we got to figure out the length of the diagonal. Okay, so the diagonal is going to be this right here, right? That's called the diagonal. That's what we're trying to find out. Okay, it says the length of the rectangle is 11. Okay, so the length is 11. We know that. We have to figure out, in order to figure out this, we need to know what this is, right? So how would we find out this? This is going to be if this is the base, right? This is the height. We need to first figure out the height, right? And then if we do that, since this is a right triangle, then we can figure out how much this is. Okay, so the first step is to calculate the height. Okay, well, we know that if the area is 99, right? So we know 99 is equal to the base times the height, right? Okay, so if we know that, that means 99 is equal to 11 times the height, right? So if we're trying to find the height, we would divide by 11, right? So the height is equal to 9, right? The height would be equal to 9. So if that's 9, let's go ahead and draw that in. I know this is high level, right? Higher level than we normally practice because it's level 3, but I know you can get this. So if that's 9, now that we know the base, right over here, let's go and highlight this to kind of get this our minds right. If I know this side now and this side, and I know it's a right triangle, now I can figure out the length of the diagonal. So let me set it up that way with our a squared plus b squared equals c squared, right? And then that's what I need to find is that c squared right over there, right? So what's our a squared? It'll be 11 squared, right? Plus our height, which is 9 squared, right? So now, if we just type that into our Desmos right over there, excuse me. If we type that into our Desmos, we're going to get that that is 202, right? Equals c squared, right? And so then we know we need to take the square root of that, right? Take the square root of that. So that's going to be approximately 14.213. Okay, so that's our answer. Approximately 14.213. So highlight that. All right, next. Derive the distance formula from the Pythagorean theorem. We need distance formula. So we remember a distance formula. That's going to be that square root of x2 minus x1 squared plus y2 minus y1. You may have remembered that, may have forgotten that from earlier in the year. All right, so we need to get to there from the distance formula. Well, if you think about it, this part right over here, that's going to be our x2 minus x1, right? Because that's the distance between there and there. So that would be like b squared, right? Plus, and then this to here, that would be our y2 minus y1, right? Because that's going to be our distance up and down, right? So y, that would be our a, and then we would square it, right, is going to be equal to c squared, right? So if we wanted to calculate this distance, right, between here and here, we would need to get the square root of that, right? So if we took the square root of that c squared, that would be the square root of that side as well. So b squared plus a squared, right? That would give us our c. So that would be our distance would be equal to the b squared plus the a squared. All right, so that's how we would calculate that. Okay, so I know it seems a little tricky when we're working with those square roots because we haven't done a lot in math classes yet, but that's how we would derive the distance formula from the square root. So that's why if you look at our poster that we have up during class as well, that's how we calculate that. So on this right triangle, A is 4, B is 5. What expression represents the value of C? All right, so if we say on this one, right, if that's 4, okay, so if we had that question, if that was 4, and it says B is 5, so that's 5, what's the value of C? All right, so that means that we could set it up, since it's a right triangle, right, we could say a squared plus b squared equals c squared, right? So we would say the a squared, which is the 4 squared, plus our b squared, which is our 5 squared, equals our c squared, right? Here's the one thing that we would recognize from these answer choices. So normally we might put that into our Desmos, but if we look at our answer choices, they have something that wouldn't be from our Desmos, right? So let's just take a look. If we're trying to find C, let's do it mathematically, right? We're going to have to take the square root of both sides. So if I take the square root of C squared, right, I have to take the square root of that side, right? So if that's the case on this right side, right, these square root and the square cancel out, so that's equal to C, which is what we want, is equal to this answer, right? So I know it's a tricky one. It's a level 3, but that's why D would be our correct answer. All right, so let's move along to our next one. Okay, so on these special right triangles, the main thing is that we need to remember how they're constructed, all right? So a special right triangle is a right triangle where it's a 45, 45, 90, and this is when it's an isosceles triangle. It's an isosceles right triangle. So that's our key word, right? Because that means two sides are congruent. All right, that's what isosceles means. So if a square, we know all the sides are the same, right? So if this one's x, that means that has to be x, right? So they're both congruent. So if we cut it with a diagonal, it'd be a 45, 45, 90, right? And the main thing is the length of the legs are going to be the same because they're congruent. But this is going to be whatever this is times the square root of 2. So if you're going from a short to a long, you're going to multiply, right? If you're going from a longer to a short, you're going to divide. Okay, so that's the main thing on that. And then 30, 60, 90, we needed to focus on our, if it was an equilateral triangle, okay, which is divided by 2. So equilateral means that they're all 60 degrees, right? So then if we cut it right there, it would make that into a 30. So that'd be a 30, a 60, and then that would be a 90, okay? And this is called, we said this in, this is called an altitude, if you remember, right? It's cutting altitude by an altitude. All right, so in that form, we have a short side, we have a long side, and we have a hypotenuse. Okay, we know the hypotenuse is across from that 90-degree angle, right? We know the shortest, smallest angle across from there is the shortest side, right? The 60 is larger, so across from there should be the long side. Okay, so if we're going from a long to a short, we have to divide. Short to a long, we have to multiply, right? Hypotenuse to a short side, we have to divide, right? If we go from short to longer side, we have to multiply. The main thing is we do not go this way. We do not go back and forth this way. We have to go this way or this way. Okay, so these are our procedures, right? If we're starting from the short going to the long, we're going to start with our number, right? And then we're going to multiply by the square root of 3. If we're going the other way, we're going to divide, right? And then we got to focus on these. So if we're going from short to hypotenuse, right? If we're going from a shorter to a longer, we have to multiply, and the factor is 2. It's 2 times. Other way, we're going to have to divide by 2, right? And then these are the critical ones, and that's probably what we're going to have on the test, and that's what we're going to show in our practice here. From long to hypotenuse. So from long to hypotenuse, we're not going to cross right over here. That's what we said. Long to hypotenuse, we're going to divide first, then we are going to multiply, right? We divide first, then multiply. If we're going backwards, we're going to divide first, then multiply, right? Divide by 2, then multiply. So we take whatever value when we do that. Okay, so let's get right into some practice. All right, so first off, we talked about how we would solve for this the missing side. We're going to use our notes, right, for the factors. Okay, so that's what we're going to do on that. We just talked about that. All right, so next, here's the level 2. Find the area of each of these figures. So let's talk about this. Area of a triangle, what is that? Area of a triangle is equal to base times height, right? Divide by 2. That's the area of a triangle. Okay, so let's first talk about this number 5 over here. Find the area of this triangle. Okay, well, we need to, let's see, the base is 20, right? We need to find the height, right? And then we can divide by 2. We're going to say the area is the base times the height divided by 2, right? So we need to figure out that height first. Okay, so what do we know? Let's check this out. We know that this is a equilateral. This one's an equilateral. Okay, that means to find this height, if that's an equilateral, that means that's 60, right? That means that's 60. That means each of these are 30. That tells us that it's a 30, 60, 90 right triangle, right? So what do we know? If we know if this is, what do we know? If we know if the whole thing is 10, right? That means this short is equal to, I'm sorry, if the whole thing is 20, the whole short is equal to 10, right? So we're trying to find the long, right? And we know that this is the hypotenuse, right? Well, what do we know? If we're trying to find the long from the short, we're going to take the short and we're just going to multiply times the square root of 3. So we're going to say the area is equal to, so we're going to say the height is 10 times the square root of 3, right? That's what we're going to calculate from there, right? So now that we know that, we're going to say the area is our base of 20 times our height of 10 times the square root of 3, okay, all divided by 2. Okay, so now this might be an answer, or we could type it into Desmos. If we put that into Desmos, we're going to get approximately 173.205. So both of these are the same answers. Same answers, right? Either one. Okay, so your answer might be something like that or something like that, but either way, just type it into our calculator and we'll see, right? This 20 times the 10 might be multiplied and then divided by 2, but either way, we'll just type it in. All right, next. Okay, so what we're going to do is to conserve some time, we're going to skip over this. And for some reason, I didn't get the next one on our paper. All right, but that's okay. All right, let's go ahead and take a look at our level 3 question. All right, so this says all answers may be in radical form. Okay, problems will have radical or use of a radical. So what is a radical? The radical is that square root symbol. Okay, that square root symbol that we've been practicing and using in class. So let's just take the square root symbol. Okay, so that's what that radical is. So when we use that, all we have to do is just to make sure, type into Desmos. All right, next. Let's keep it moving.